This is the activity on understanding square numbers. The objective of this activity is to understand the patterns and the properties of perfect squares and how they are related with odd numbers, the triangular numbers, and to explore the concept of square roots. So let's understand what are square numbers first, and then we will see what are triangular numbers. First, we will talk about the square numbers. As the name suggests, the number of rows and the number of columns have to be equal. Like 1 is a square number because 1 square gives us 1. If we arrange 4 beads or counters in 2 rows and 2 columns, we get 4 such beads and 2 square happens to be 4. Likewise, if we have to get 3 square, which is 9, we will require 9 beads and we can arrange them in rows containing 3 beads each, like this. So 9 is also a square number. And similarly, if we talk about triangular numbers, as the name suggests, now we have to form a triangle. So 1 is a triangular number, 1 and then 2 more below this like this. This gives 3. So 3 is the next triangular number. And likewise, if we add one more row containing 3 beads like this, so there are total 6 beads and that also becomes a triangular number. The next will contain 4 beads in the fourth row like this, and the total number of beads will be 10, and so the next triangular number is 10. So in the activity we will be studying the properties of all these square numbers and all these triangular numbers. The material required to conduct this activity are counters, or you can use beads of different colors. We need square grid paper, chart paper, markers, ruler and pencils, which are the normal aids. So let's see how to perform this amazing activity. So to perform this activity on square numbers and triangular numbers, you can see we have kept here some of the counters. You can use beads also. Anything that is readily available and which are more than like 15 numbers, that will work for this activity. Here we have the observation table where we have the serial number and then the number of counters used, and then we have the observation. Now in the first attempt we are going to study the square numbers. So the first thing we are going to do is to have 1 here, 1 counter. That means in the number of counters you will just write 1. Why we have used 1 counter here? Because 1 times 1 is actually 1 only. So 1 is the first square number. Likewise, if I use now a 2 by 2 square, like 2 counters like this and 2 counters below this, we have a total of 4 counters. So number of counters used are 4, and therefore 2 times 2 makes 4. So 4 becomes the next square number. Likewise, you can have a row containing 3 different counters, somewhat like this, and the second row again will contain 3 counters placed symmetrically below the first row, and likewise we will have the third row in which we will have 3 counters again, and you will find that the total number of counters we have used to make this matrix is 9. Why? Because 3 times 3 is 9. So all these numbers which we are obtaining, 1, 4, 9, they are called square numbers. Likewise, if we use 16 different counters and arrange them in rows of 4 counters each, then we will have 16 counters, and 4 times 4 will give us 16. And this process can go on and on. Likewise, we can relate these square numbers with the square root of a number. Here you can see this 4 square is coming out to be 16. It means that when you take the square root of this square number 16, it will give you the answer as 4. So square root is actually the inverse operation of squares. Likewise, if we have to study the triangular numbers, the same counters can be arranged in the form of triangles. So the number 1 is the first triangular number, and then coming on to the next pattern, we have a row containing 2 counters now, like this, and you can see this resembles the shape of a triangle. So 1 counter, and then here is 1 counter, and then in the next arrangement here we have 3 counters, 1 2 3, and the arrangement will be somewhat like this. And then the next one, if we want to expand this, we can have a row containing 3 different counters like this, and we will have another triangle formed. And if you count the total number of counters used here, they will be 6 in number, and the pattern will be 1, then 2, and then 3. And likewise, you can expand this to any number of rows. It will form a even bigger triangular number. So I am keeping 4 in the next row here. Like this, it forms another triangle, a bigger triangle, and the total number of counters used are 10. So the arrangement will be something like this. So this is a big triangle being formed. And likewise, the next row will contain 15. So the next row will contain 5. So the total number will be 15. And the 15 forms the next triangular number. So you can keep on expanding this as per requirement, and that completes our activity on rectangular numbers and triangular numbers.